Hello, everyone, and welcome to today's live broadcast, Protect Your Evidence, Protect Yourself, Advanced Enclosures for Forensic Labs, presented by Kelly Williams and David Wasesha, Product Managers, LabConco Corporation. I am Kaylee Bach of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is brought to you by LabRoots and sponsored by LabConco. For more information on our sponsor, please visit labconco.com. Now let's get started. Before we begin, I would like to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. To do so, simply type them into the Ask a Question and click the Send button. We'll answer as many questions as we have time for at the end of the presentation. Also, please notice that you will be viewing this presentation in the slide window. To enlarge the window, click on the arrows at the top right-hand corner of the slide window. If you have trouble seeing or hearing the presentation, click on the Support tab found at the top right of the presentation window, or report your problem by clicking on the Answer a Question box located on the far left of your screen. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located on the top right of the presentation window and follow the process to obtain your credits. I'd like to now introduce our presenters, Kelly Williams and David Wasesha. Kelly Williams is a product manager for forensic lab equipment at LabConco Corporation. Kelly has helped LabConco customers with their application and equipment needs for more than 17 years. She has a BA in biology and an MBA in marketing. Prior to working with LabConco, Kelly conducted endocrinology research in biochemistry lab. David Wasesha is a Kansas City-based product manager for LabConco Corporation. David manages LabConco's particulate containment enclosures for nanotechnology and pharmaceutical applications. Although a microbiologist at heart, David has also worked in pharmaceutical analytical chemistry. Other products in David's portfolio include water purification products, glassware washers, and glove boxes. David joined LabConco in 2015. Kelly, you may now begin your presentation.
Thank you, Kaylee, and thank you for joining us today. We're going to talk about advanced enclosures in forensics labs. And we have been involved in in the planning and construction and renovation of many new forensic crime labs all over the country in the past 5 years. And we thought today we would share what we are seeing in these labs and exactly how lab equipment is changing with the new demands on them. The first trend that we're seeing in the forensics labs as far as the equipment and generally in all labs is the protection of laboratory personnel is increasing. Regulations have increased, and as well as people's awareness about the hazards that are present in the lab. Now, workers and people that work in the lab want protection from these fume hoods and closures for even methods that they used to have on the open bench. So the attitude is, why take the risk when you don't need to? And as a result, people are using more hoods and enclosures. And these, when I say enclosures, they're like specialty hoods that are getting more specialized, specific to different applications. Another trend that we're seeing is increase in evidence protection. With DNA being the golden standard in the courtroom, and analytical equipment in general becoming much more sensitive, it doesn't take much to contaminate a sample now. So evidence is critical, and people do not want their evidence to get contaminated. So they're using different ways to protect their evidence and reduce the risk of contamination. The other trend, the last trend that we're seeing is the increase in sustainability. This is a huge trend, especially when you're talking new construction or renovation. Anytime that someone is changing the building or the equipment in the building, they're wanting to reduce the operating costs and become more environmentally friendly. And as a result, sometimes these trends can be in opposition of each other, meaning in general, when you add more fume hoods or enclosures, lots of times they require the air movement for that containment or that protection. So in essence, you can increase your operating costs by adding just standard hoods and not taking in the sustainability factors into the equation. Common laboratory equipment in forensics labs are biological safety cabinets, PCR enclosures, fume hoods, evidence drying cabinets, CA fuming chambers, fingerprint powder stations, and powder containment hoods. The last 5 items that are highlighted there are the ones that we're going to discuss today. Although we do supply all of these types of equipment to forensics labs. The first one that I would like to start with is an evidence drying cabinet. And specifically, what is this evidence drying cabinet doing and what makes it safe and effective? Back in the day, a lot of people used to dry evidence in fume hoods, or they would even have a shower stall that they would dry evidence in. And as forensic science has advanced, so has the requirement for this drying procedure. And basically what the evidence drying cabinet offers over these shower stalls or fume hoods is safety. Generally, when you're drying evidence, it's a biological hazard because it is being dried because it has body fluids on it or other liquids that can make the body fluids more hazardous. So the first thing that the evidence drying cabinet is going to have is a HEPA filter. This HEPA filtered exhaust reduces the biohazard risk for the rest of the lab. So if you are using a shower stall and it's just drying there, you're not doing anything with the air that could be passing over that evidence to protect the rest of the people in the lab. So the HEPA filter is critical. Also, there is a carbon filter. The carbon filtered exhaust is mainly there to eliminate odors. So this exhaust is being both HEPA filtered and carbon filtered. Evidence drying cabinets provide a means to lock the cabinet. We're going to maintain our chain of custody. If you just put something in a fume hood, it's very hard to lock that fume hood and maintain the chain of custody unless you lock the whole room. So being able to secure your evidence very easily in a cabinet is a nice feature. Not only do we want to protect the lab workers from the biohazards, we also want to protect the evidence. So like I mentioned earlier, the DNA standard being the standard in the courtroom and the sensitivity of analysis has made it very critical to protect that evidence. So a cabinet, when operating properly, is going to have a pre-filter to prevent cross-contamination of that evidence. Other things that you need to consider are, because you are putting a biohazard in a cabinet and then you're going to need to clean that cabinet, you're going to need to look at the surface of what that cabinet is made of. If it's plastic or porous, you may not get it as clean as you want or decontaminated as you want. If you look at other industries, such as medical industry or food industry, they're using stainless steel. And that's what we choose to use in our cabinets. We really feel like this is a very cleanable surface and one that is the golden standard for being able to be decontaminated. To aid in that decontamination, we also, in some of our models, add a UV light. The UV light is for secondary decontamination. And so you would clean your cabinet still, but then you would use your UV light for secondary decontamination. What's really nice about the UV in this application is that UV denatures DNA. So in evidence, we're very concerned about DNA. So being able to assure that you're putting new evidence into a DNA-free cabinet is a very nice feature to have. Evidence drying cabinets come in a variety of sizes, and you can go anywhere from a benchtop cabinet up to a 5-foot wide cabinet. The main thing is that you're going to want to make sure that you have enough room to dry the evidence that you typically see coming into your lab. It's common for evidence drying cabinets to be banked together, like these pictured here. And it's also very common for the cabinets to be located where the evidence is coming into the building. You want to minimize the movement of the evidence, and you want to get them into a cabinet as soon as possible. So to protect the building and the workers in the building, but also to protect that evidence. Here you will see that these cabinets are ducted. Some cabinets cabinets can be ducted or non-ducted. It just depends on the preference of the laboratory. Like I mentioned earlier, when you're looking for cabinets, material of construction is very important. Our cabinets use a stainless steel liner, and not only does this give superior cleanability, but it also does make it very resistant to the UV light and germicidal cleaners. So you want, if you're going to be purchasing a cabinet, you're going to want a cabinet that will last and last. And so it's very critical that you look at the materials of construction. Like I mentioned earlier, having a DNA-free environment is a big plus when you're processing evidence. However, you want to make sure that DNA cannot be accidentally, the DNA or the UV light can't be accidentally turned on. If you were to load your samples or evidence and then turn the UV light on, you're going to denature the DNA that is on that evidence. When designing our cabinets, we thought of this, and we made our UV light require a security lock. So in order to turn the UV light on, we do have a security lock that needs to be turned on for that UV to work. So you can't accidentally denature the DNA on your evidence. The next section of the forensics lab that we'd like to look at is the latent print section. And in the latent print section, you're going to find CA or superglue fuming chambers, fume hoods, DFO chambers, fingerprint dusting stations, large sinks, bench and tables, and you're also going to want to make sure that this whole area, the rooms themselves, have proper ventilation. There's a lot going on in these rooms, and it's always a plus to start out with a well-equipped room. Okay. The first thing I would want to address is the CA fuming chambers. Pictured right here is an automated CA fuming chambers. When you're talking about CA fuming chambers in general, there is a big trade-off between the amount of glue you use, the types of glue you use, even the tin that you use, the temperature that you're heating to, and the fuming time. These are all affect each other. So it's critical to look at your process and to make sure that when you adjust one, that you're adjusting the other one to get great results. That is what's really nice about an automated fuming chamber. Because the different parameters, the different factors that I mentioned greatly affect each other, it's very nice to have an automated fuming chamber where you can be assured that how you ran your fuming method yesterday is the same that you're running it today as the same that we'll be running tomorrow. Getting great prints is something that just doesn't happen. You need to be able to control the parameters and ensure that you are getting the high standard results that you expect. The automated fuming chamber makes this whole process a lot easier. The process, you're controlling your humidity level, you're controlling your heating, you're controlling your exposure time, and you are our Capture VT is our fuming chamber will also help you automate the ending of the procedure to ensure that you don't overfume it. Air circulation is a critical process parameter during the fuming stages. You're going to want to make sure that your cabinet has great airflow patterns, meaning you don't have hot spots, that the evidence that is closest to the fumes being generated get more exposure than the far corner of the cabinet. So having even airflow patterns during the humidification, the fuming, and the exhaust is very critical to have consistent results throughout your cabinet. Humidity level is a critical parameter in the fuming stages. It's important that you can, it will make it a lot easier if your humidifier is built in, and also if it can be calibrated. Calibrating both your humidity level, your humidifier, and your hot plate will help ensure that you get those standard repeatable results day after day. If your cabinet does not have a way to calibrate the humidity level or the temperature plate, you might you want to make sure that you stay on top of this and take regular readings and make sure what you believe to be the same parameters are really happening. The humidity, optimal humidity level for fuming is between 70 and 80% humidity. So if your humidifier is drifting, you may not be in that optimal window of great development. It will not only affect the quality of your results, but will also affect how easily they can be disrupted. Meaning, if your humidity level is not between 70 and 80%, it is very easy to smear those prints that you have developed. So when you take your evidence and put it in the evidence room, there's a good chance that you could lose that print just in the handling and the packaging of that evidence. So a humidity level that is consistent is very important. Here we are looking at some accessories. When you're picking out a CA fuming chamber, it's important that you look at the size and the dimensions when picking out that cabinet. One of the most common measurements that people measure or judge their cabinet by is the diagonal. The diagonal measurement is going to be the longest piece of evidence that you can put in there. So you want to make sure that your cabinet has a large area for you to accommodate the evidence that enters your lab. Another thing that you're going to want to look at is the accessories. Your accessories are going to help you maximize your chamber and also make it easier to fume certain pieces of evidence. When you compare cabinet to cabinet, the size, the dimensions, where the controls are, what accessories are available with those cabinets are all important things to consider. Unfortunately, cleaning your CA chamber, your CA fuming chamber, is going to be something that you are going to regularly have to do. When you are CA fuming and you get over processing and you get buildup of the CA deposits on the cabinet over time, what will happen is the CA will be more attracted to those deposits than they are to the evidence. So over time, you're going to have to add more and more CA to get the same results and the same great prints that you were previously getting. And this is a vicious circle because then that will mean more and more cleaning that you're going to have to do of your cabinet. So it's critical that these cabinets get cleaned regularly. And one thing that you're going to want to look at when you're picking out a cabinet or a chamber is how easily does the CA come off of that chamber. Being able to clean it is important, and being able to clean it easily is even more important. Our Capture BT fuming chamber uses stainless steel. We did testing on a lot of different materials, and the stainless steel was the one that was easily cleaned the most easily. And also, it can be cleaned with just stainless steel cleaner, which happens to put a very thin coating on the stainless steel that actually inhibits the CA deposits. So having a chamber that's easily cleanable is a big plus. Also, when you're looking at cabinets, some of the new things that have been coming out that people have worked on for years is typically when people CA fume, they then do staining. There's been a lot of effort going into finding superglue or modifying superglue so that it will fluoresce, or it will, by that fluorescence, it will eliminate the need to stain afterwards. So essentially, you're turning the two-step fuming and staining process into a one-step process where you simply fume with special glue, and then you can get actually excellent prints with the luminescence. It almost adds a third dimension where the prints literally almost pop off the media at you. In order to accommodate these new glues that are hitting the market, you need the ability to adjust your temperature to ranges that cabinets have not, or fuming chambers have not been to before, and you need to be able to adjust your fuming time. So looking at chambers, if you have a chamber that you can program, and you can change the programs to the parameters that you specifically want, that is a nice feature to have. Here's a picture of those fluorescent prints using lumicyano, and you can tell that they're excellent prints and they're very, very easy to read. Other factors to consider when you're getting CA fuming chamber is how easy is it to use? Is it repeatable? What kind of flexibility do I have to change the programs for the new glues or techniques that are coming out? Because when you buy this chamber, you're going to want to have it for years and years. So being flexible and being able to accommodate new things that develop are important. Does my chamber prevent overexposure? Meaning, can I start my cycle, walk away, and not have to be worried, or be right at the cabinet or chamber when the fuming exhaust is, or fuming phase is done, to ensure that my prints aren't overexposed? So overexposure prevention can really bring a peace of mind. Maintenance requirements, how easy it is to clean and maintain, what sort of filters, what is my filter life, are important questions to ask. And also, you want to make sure that whoever you purchase this from has the ability to support and service your cabinet. You're going to have this chamber for a really long time, so you want to make sure that that company will be there to support that product over those years. Another item in the latent print section is fume hoods. And we have seen dramatic changes in fume hoods over the past 10 years. The need to contain has increased. So people are expecting higher and higher containment levels, while at the same time they're expecting this containment to be maintained with less amounts of air. So what has developed are what they call high-performance fume hoods. A typical good old standard fume hood, you will have containment at around 100 feet per minute. To be classified as a high-performance fume hood, the fume hood will need to have that same containment, but will need to do it at a reduced amount of air, typically around 60 feet per minute. And it doesn't sound like that big of a difference, but right there, by going from 100 feet per minute to 60 feet per minute, you're reducing the amount of air or tempered air through that fume hood by about 40%. So if we look at yearly operating costs to operate a typical normal fume hood, you're looking, and it will vary depending on what area of the country you live in, and how much heating and air conditioning that you have to do to the air in your laboratory. But on average, it costs for a standard fume hood about $6,867 for the operating cost of that fume hood, and that's just in conditioning the air that is leaving it. If you were to use a high-performance hood instead of your standard fume hood in that application, your average cost is around $3,920. So right there in 1 year, you're saving over $3,000 in one fume hood. So you can imagine if you have a building that has 6 or 8 fume hoods, you can significantly affect your operating costs, yearly operating costs. So that is just 1 year. So you can times that how many years you think you're going to be in that building. And generally people build their buildings for a very long time. So it doesn't take very much time for in new construction or renovations to get the payback or the return on that investment by going for a high performance fume hood over a standard fume hood. Another area that has developed to increase sustainability and provide protection is filtered fume hoods and enclosures. We are seeing these become more common in that, and in filtered fume hoods, you want to make sure that you are doing the same application over and over in that fume hood, because each application that is done in a filtered fume hood should be what the process is and the chemicals that are used in the application should be analyzed before it is done in that fume hood. You're depending on those filters to protect yourself and everyone in your lab. So you want to make sure that your method and what you're doing is compatible with those filters. So the filtered fume hoods are great ways to increase sustainability and that safety factor. You just want to make sure that your application is fitting for that hood. But these enclosures and filtered fume hoods are getting more and more popular every year. Another enclosure for forensics labs that increases sustainability and reduces operating costs is the fingerprint powder station. This unique enclosure was designed specifically for fingerprint powder. You will notice that it has an open design in order to allow you to fingerprint powder large pieces of evidence. The air in this enclosure is being drawn down through the work surface that has a lot of different holes in it and to the back of the enclosure. The pattern of the work surface is designed so that you have equal down airflow throughout the work surface. Even if you're in the front or the back of it, you're going to have equal flow. So that is very good in order to capture all the powder. This decreases energy consumption because you're using a pre-filter and a HEPA filter. So the air that you're pulling into the enclosure is going right back into the room. So you are not losing air that you've paid money to temper. The other thing that's great about the fingerprint powder station is that it frees up your fume hoods. Without such an enclosure, people will use a fume hood to do fingerprint powders, and what will happen is they will get fingerprint powder all over that hood, and no one else in the lab will want to use that hood because it will be quite messy. Once you get the fingerprint powder behind a baffle and such, it's almost impossible to clean. So this fingerprint powder station will free up your fume hood for chemical usage, and it will also return the air to the room. I'm going to turn it over to Dave, who is going to talk about the safe handling of powders in laboratories.
Great, thanks, Kelly. I'm going to talk a little bit about some of the different options that are available for containment of hazardous drug powders. No question, the hot topic in forensics lately has been how to handle opioids that have been taken out of the field and brought in for analysis. So first thing I'm going to do is talk a bit about some solutions, or I guess some common mistakes that are made in the lab, and then I'll transition over to some solutions that are out there for different containments of these hazardous powders. So without further ado, first thing I want to take a look at is an environment we certainly want to avoid in a laboratory. So here's our friend Al Pacino sitting in front of a bit of a mess on the laboratory bench. And you can imagine if this was in your laboratory, it might cause a pretty big concern. The reality is, though, that not all powders are needing to be in such large volumes to be hazardous. If you have a mound of powder like this, obviously not great, but there are certainly some extremely potent pharmaceutical powders that are being seen frequently that can be much more hazardous and in very small quantities. So just a quick analysis of some bench good and bad practices. So here's a woman who's working with some powders. She's measuring something out, and it looks to the untrained eye, just a quick look at her PPE. Everything looks good. She's got gloves on. She's got a breathing mask of sorts. But if you look a little bit closer, you see there are a lot of practices here that if she were weighing hazardous powders or measuring hazardous powders out, there's some causes for concern. So first thing first, she's on the open bench. She's got her contaminated parts of her container, so her cap, a Kim wipe, a mask that is not the most ideal filtered mask. All of these are causes for concern in the laboratory if you're working with extremely hazardous powders. Well, so if we move this to a hood, say the thing behind her, there are a couple other things that are still problematic. So not all hoods are safe, and what I mean by that is there are specific hoods for specific applications. Kelly talked about a few of them. So if we looked at just a typical vented fume hood, which is ideal for handling hazardous chemical vapors, they miss out on a couple of important details for capturing hazardous drugs. So the first one would be that they're not filtered with a HEPA filter. A HEPA filter is a high-efficiency particulate air filter that's meant specifically for capturing hazardous powders. In a fume hood, that would not exist. Fume hoods also typically have a higher face velocity, so the airflow moving into the opening in the enclosure where you're working is typically going to be quite high. So that means that powders can fly around readily versus a couple of powder containment solutions that we'll be talking about in a bit. Remember, fume hoods are designed for capturing gases coming off of chemicals, so definitely a different behavior than a particulate affiliated with a hazardous drug powder. The other thing that's a big concern is, okay, well, no filter and a whole length of ductwork. Well, anything that I'm going to be weighing or manipulating that's going to leave the work area is going to be carried into the ductwork, into the remote blower, and then out onto the rooftop of the lab where I'm working, which means that if I ever have to go modify that ductwork, or if there's a leak, or if someone's on the rooftop servicing the blower, or maybe just replacing a filter somewhere else for the building supply air, they potentially could become exposed to anything that has escaped from the lab into that contaminated duct run and onto the rooftop. So you have to think about not only what you're doing and where you're taking handling your hazardous materials, but where they're going to be going after they've been drawn away from where you're working. There's another type of hood that's used known as a ductless hood. Sometimes a filtered fume hood is another terminology for it. And Kelly mentioned these earlier. These are really, again, common because they allow for laboratories to protect themselves without having to tie into an exhaust system. But they are carbon filtered hoods first. So carbon filter is excellent at containing and absorbing a number of chemicals, vaporous, gaseous chemicals. But when it comes to capturing a hazardous drug particulate, such as, say, fentanyl, they're not really ideal because they are looking for a gas to be bound rather than just simply stopping a particulate. I see a lot of forensics labs looking for ductless hoods. If you're looking for a ductless hood, you want to be sure that it's not just a carbon filtered hood, because that will really not protect you from fentanyl or other hazardous opioid drugs. If these enclosures do have HEPA filters, typically that filter is not going to be anything more than a simple small HEPA filter intended for capturing some dusts or nuisance particulates. Certainly not for use for hazardous drugs. And in part, that's because the HEPA filter is typically without what's called a bag-in, bag-out, or BIBO filter housing. The bag-in, bag-out system is, in short, a physical bag that allows you to remove a HEPA filter from a contaminated area inside a enclosure, so that when you have to go replace a filter, you're not just pulling out loose dust into the room that might contain hazardous drugs such as fentanyl. Like any other chemical fume hood, oftentimes ductless hoods are run at faster face velocities, which means that air coming into the enclosure is going to be turbulent and could potentially cause some swirling of particulate matter back out of the enclosure, unlike with gas, which is easily swept to the back and out through the venting system. So there are a couple of recommended enclosures for hazardous drug powders, and I'm going to talk about 3 different formats of them. You see here just a couple of quick pictures of these. So they look like hoods or containment boxes, but they have specific characteristics that benefit capturing particulates. Okay, so the first hood that's typically used to contain fentanyl is what's called an expert system, which is a type of powder containment hood. These are negative pressure hoods that work similarly to a fume hood in the sense that they're pulling air away from an operator into the hood and then out through some kind of exhaust. Powder containment hoods are different than fume hoods because they utilize a HEPA filter, and ideally this HEPA filter should be in a bag-in, bag-out setup where the powder is going to be captured onto the filter, and when it comes time to replace that filter, that process can be done by removing the filter into a bag rather than just out into the laboratory. A really nice way of thinking about the bag-in, bag-out system is if you were to go change your home furnace filter or your home AC filter, you're going to pull it out and see all of the contaminants on that filter. Well, if they were hazardous drugs, ideally you would want to pull them into a sealed bag. And that's what the bag-in, bag-out process is doing. It's separating the contaminated filter from yourself and the laboratory. Other important things about containment powder enclosures are having airfoils and a baffle that promote turbulent-free air movements. And typically you want these enclosures to be tested by a third-party source to know that these are effective at containing hazardous powders. So SafeBridge is one example of a company that tests these enclosures. And what you want to look for is data that represents containment at a level that's as good or better than what the operational exposure limit is of any hazardous drug you might be handling. These enclosures are typically ductless in a sense that they're moving air back into the laboratory rather than through exhaust ductwork, and that's typically because powders are not giving off hazardous vapors or fumes that are not desirable to breathe. So for a laboratory to install one of these products, it's typically very simple, just setting it on the bench. You want to make sure that you can exhaust these hoods if possible. Should your application change and you require the use of either something that's a smelly sample or you're using light-duty chemicals such as methanol or acetonitrile to dilute the product that you've brought in from the field. So a quick look at how containment is promoted by this enclosure design. You'll notice there are several arrows representing airflow moving from left to right. So left would be where you're standing on this side view. And you'll notice that there are shapes of these airfoils that are promoting airflow into the hood that are smooth and ensuring laminarity or smooth, non-turbulent airflow, which is important when containing particulates that can typically have a very light mass and may easily escape an enclosure that is turbulent. In some cases, it's desirable to have a second HEPA filter if you're concerned with maybe an extremely potent hazardous compound, maybe carfentanil, sufentanil, something that's not easily controllable, and you have workplace concerns about its containment. A second HEPA filter can help alleviate some of those concerns. So here this view is showing the front panel off of a double HEPA filtered enclosure, and you can see the yellow bags, which are the bag-in, bag-out systems, which help when removing either filter should it become contaminated during the loading over the course of several years. Another enclosure that is sometimes used for fentanyl or hazardous powder containment is a glove box. This is simply a sealed chamber that provides a complete physical barrier between yourself and the product that you're sampling for testing. In this case, you're going to be working through gloves. There's a transfer chamber that should always exist on these types of enclosures that allows for an intermediate pass-through into the device. And these utilize HEPA filters or sometimes ULPA filters. Their goal is to trap powders from escaping through the glove box, but again, allowing workers to handle in a sealed, contained system. When it comes time to change out HEPA filters, you again want to make sure that your isolation glove box is going to have a bag-in, bag-out process for changing those filters. And that's just important to make sure that you don't expose the laboratory to these hazardous powders that you've been working with inside this containment chamber. So those are a couple of quick ways to address fentanyl or hazardous powder containments. And at this time, I want to just reiterate that we've got some time set aside for Kelly and I both to answer questions on our various hoods and fingerprinting stations and fentanyl containment devices. So thanks so much for attending, and looking forward to your questions.
Thank you, Kelly and David, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Answer a Question box located on the far left of your screen. We'll answer as many of your questions as we have time for. Let's get started. Our first question is, we are handling large packages of evidence that may contain fentanyl. What enclosure should we use?
Great question. So a lot of times in laboratories, the volumes are really small, maybe a milligram up to a gram. But what do you do if you take a big package of hazardous powder into your laboratory? Well, the biggest thing you want to make sure is that it will fit into an enclosure. So it's important to consider that when looking at hoods. Make sure you've got enough size. But if you're dealing with a really large package that might contain a huge volume of fentanyl, definitely might be a consideration to move into a glove box, because you never know what's going to happen if you open that box. Sometimes you can generate powders, and they might be able to overcome the speed of air flowing into a hood. So a glove box can be a good way to completely seal off and isolate yourself from a large volume of hazardous drugs.
Thank you. The next question we have says, we are currently using a closet to dry evidence, and it works fine. Why should we use a drying cabinet?
I'll go ahead and take that question, and that's a good question. And I do know that evidence was dried in closets or rooms or even shower stalls for quite many years, for a while ago. But what makes an evidence drying cabinet better than a closet is the protection it's giving to your evidence and to you. When you put evidence in a closet, that's a biohazard. So if it's dripping with stuff, it's pretty hard to ensure that your closet is completely clean because of the different crevices that could be in the closet or that type of stuff. The other thing is that an evidence drying cabinet includes a HEPA filter. So the air that's coming out of there is HEPA filtered, where in a closet, especially when you open the door and that kind of stuff, it can be exposed. So protecting your evidence and it is done more effectively in an evidence drying cabinet. Our cabinets do have stainless steel, so you can decon that and UV light to denature any DNA that's left around or biohazards. So it's going to denature any viruses or bacteria that were in that blood or body fluid that is then in your room that that can harm you. But excellent question.
Thank you, Kelly. Our next question says, can we modify our current fume hood to use less air?
Fume hoods cannot be modified to become high performance or use less air. A high performance hood is designed to contain while using less air. Your typical fume hood does require a certain phase velocity in order for containment. But so if you lower that phase velocity, you're not going to be guaranteed containment in that hood unless you test it, and that hood has been designed specifically to contain with less airflow. So it's a lot more complicated than it seems than just using less air. There's a big trade-off, and safety is definitely something that you do not want to mess with. So you need to use the phase velocity of your fume hood that it's been rated for.
Okay, and we have time for one more question, and this last one asks, do we need to exhaust a fentanyl containment hood to the outside of our building?
Great question. If you're venting a hood to the outside, typically it's because you've got something that's smelly, or you've got a chemical that needs to be vented to the outside that can't be breathed or recirculated back into the room. Fentanyl and most drug powders by themselves are not volatile and don't give off gaseous chemicals, which would not be trapped by a HEPA filter. The powders themselves would be, though. So in most cases, a HEPA-filtered enclosure that's just recirculating to the room is acceptable. However, many analysis techniques for small molecule drugs like fentanyl require dilution into some kind of solvent as a primary step. So whether that's methanol or acetonitrile based or some other solvents, most often those are being worked with in volumes that are generating enough volatile hazardous chemical to need to duct that outside. So best thing to do is analyze the steps that you're going to take to analyze whatever hazardous drug you're working with, and if it includes a gaseous or vaporous volatile chemical that would traditionally be exhausted in a fume hood, and the answer is that you very likely need to exhaust the hood that you're using for fentanyl analysis.
Thank you again, David, and thank you as well, Kelly. Do either of you have any final comments for our audience?
No, thank you for joining us today. And if you have any questions or if there's any equipment that we can help you with, don't hesitate to contact us. We get emails and calls all day long from people with specific questions. So we would be happy to help.
Before we go, I'd like to thank the audience. I'd like to thank the audience for joining us today and for their interesting questions. Questions we do not have time for today or those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. We would like to thank LabRoots and our sponsor, LabConco, for underwriting today's educational webcast. This webcast can be viewed on demand through December of 2018. LabRoots will alert you via email when it is available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, goodbye.